what we're going to be learning in this section is how to find the minimum and maximum for a function in 3-dimension space, not like a standard 2-dimension. So you will be given a function in the two variables x and y, and you will be asked to find, we call them relative maximum minimum values for a given function. So to do that, there is a procedure here actually it needs to be done. And this procedure, or we call it a test, or specifically the d-test. So the d-test said, if we have, let f be differentiable, that we can differentiate, differentiable function of x and y, and let a comma b represent the solution of the system of equations f sub x equals 0, f sub y equals 0. So for the given function, you're going to be finding f sub x and f sub y and set them equal 0. And then solve. You know, when you solve, you get x and y. You get 1 or 2 points, who knows, depends. And let, after that, d equals f sub x evaluated at ab times f sub y evaluated at ab minus fxy evaluated at ab all squared. Then what happens? Four things might happen. The first one, if d is bigger than 0 in value and the fxx when evaluated at ab is less than 0, then this tells us that f has a relative maximum at ab. That's the first case. If d is still positive and fx evaluated at ab is positive, then f has a relative min at ab. If d is negative, automatically follows that f has neither max nor min at the point AB. And the last case, if d equals 0, this test fails to work. So you have to use some other tool to find it out. That's the major thing in this section, is how to apply the d-test to find relative min and relative max. So we are going to look at an example to see how to apply such a thing. So determine the relative max and min values of the function fxy given by x squared plus xy 2y squared minus 7x. Again, the procedure we have to find, if you look at the d-test, they need xx, fyy, fxy. So let's start with fxy. So to find fxy, remember we find fx first, which is 2x plus y minus 7. Then fxy is going to be the derivative of, or if you like to find fy as well, we're going to use it later on. It's x plus 4y minus 0. So the derivative of 7x is 0. So for fxy is you find the derivative of fx with respect to y, which is 0 plus 1 minus 0. And if you want to find fxx is the derivative of x with respect to x again, which is 2. fyy, it's 4. Remember, what we need to do is find fx and fy and set them equal to 0. So we have to make a system fx equals 0, fy equals 0. We found fx. Fx is 2x plus y minus 7 equals 0. Fy is x plus 4y equals 0. We got a system of equations to solve. I'm sure everyone knows how to solve this. You can multiply this by -2 to use elimination method. So the first equation, you can add 7 to both sides. -2x minus 8y equals 0. Add them up. -7y is 7. So y is -1. We got y. If you substitute it in, x would be 4. Okay, x is going to be 4. So x, again, x is going to be 4. So there's only one point, one point here. This point is called a critical point. So now, remember D, the one I give you earlier, it's fxx evaluated at that point times fyy evaluated at the same point minus fxy evaluated at the same point square. So fxx is already 2. I can't do anything there, just put 2 there. Fyy is 4. That's the easiest when you got numbers. You don't have to plug more in. Fxy, it's 1. Hey, I don't have to substitute that in. So that's 8 minus 1. That gives me 7, which is bigger than 0. So let's go back up. It says if D bigger than 0, we need to look at fxx. Let's see, fxx, it's 2. It's already bigger than 0. And I'm going to write and fxx is bigger than 0. So the test said, the D test said, if both of them are bigger than 0, if both of these D and fxx are both bigger than 0, then this tells us then by the D test, f has a relative minimum at that point, the critical point that we found. And to find the minimum value, we substitute the points into the function. So the function was fxy. The equation of the given function was x squared plus xy plus 2y squared minus 7x. So all we have to do is just evaluate this at the critical point. So f of 4 comma -1. So 4 squared plus 4 times -1 plus 2 times -1 squared minus 7 times 4. So that gives us 16 minus 4 plus 2 minus 28. And that would be -14. Same for another example. fxy equals x squared plus xy plus y squared minus 3x. Now, so first thing we find fx, which is 2x plus y minus 3. We find fy, which is x plus 2y. From here we can find fxx, which is 2. fyy is also 2. We need fxy. That's basically you take the derivative of fx with respect to y of this one, which is 1. When you get these fxx, fxy, and fyy numbers, it makes things much easier. So now before d, sorry, we need to set fx and fy both equal to 0. So we get 2x plus y minus 3 is 0, and x plus 2y is 0. So to eliminate, let's say the x, you multiply by -2 here. So the first equation, add 3 to both sides. You get -2x minus 4y equals 0. These cancel out. -3y is 3. We got y to be -1. Then we know that x plus 2y is 0. You substitute -2 in. So you get x equals 2. So we get a point 2 comma -1 as a critical point. Now we can move on. Then the d test, remember, is fxx evaluated at that point times fyy evaluated at that point minus fxy evaluated at that point square. Let's see what we get. Fxx was a number 2. Fyy is also 2. Fxy is 1. So that gives us 4 minus 1, which is 3. Notice it's bigger than 0. If it's bigger than 0, we need to look at fxx. Again, fxx is 2. It's also bigger than 0. So that tells us the point 2 comma -1 is a relative min by the d test. So the d test tells us so. To find the minimum value, what do? We evaluate the function. Let me write the function again. X squared plus xy plus y squared minus 3x. Evaluated at that point, 2 comma -1. So it's 2 squared plus 2 times -1 plus -1 squared times 2. That gives us 4 minus 2 plus 1 minus 6 minus or -3. So in business applications, this has applications to that helps us to find min and max values based on some constraint functions like minimum cost, the maximum revenue, things like that. So as an example to business stuff, let's say a company produces two types of solar panels per year. X thousand of type A and Y thousand of type B. The revenue and cost equations. Those will be in millions of dollars. For the year are given as follows. The revenue R of XY is 3x plus 4y, and the cost CXY is x squared minus 4xy plus 5y squared plus 9x minus 18y minus 9. We need to determine how many of each type of solar panel should be produced per year to maximize profit. Well, so how do we maximize the profit? Well, we need a function for the profit, right? What's the profit? Well, to find the profit function, call it P of X. Let P of XY be the profit function. How do you find the profit? We take the revenue minus the cost. So 3x plus 4y minus, open a parentheses, x squared minus 4xy plus 5y squared plus 9x minus 18y minus 9. And what we need to do with this is to simplify by multiplying the negative sign in. Plus 4xy minus 5y squared minus 9x plus 18y plus 9. Combine like terms, negative x squared plus 4xy minus 5y squared minus 6x plus 22y plus 9. That's the profit function. So now to find the min or max, we need to find P sub x, which is negative 2x plus 4y minus 6. P sub y, 4x minus 10y plus 22. Set each one equal to 0. So we got a system here. How do you solve it? Maybe I want to eliminate the x, so multiply the first equation by 2. 8y minus 12 equals 0, and keep the second equation the same. We're going to solve for x and y. This eliminates this. Negative 2y plus 10 equals 0. And solve for y. Y is 5. We got y5. Maybe I can substitute in the first equation. Negative 2x plus 4y minus 6 equals 0. Substitute the y, 5. And let's see what we get. Negative 2x plus 20. 20 minus that is 14. Solve for x. X is 7. So we got x and y. So that's called the critical point. Now we need to find Pxx. If you look back at that, that's a -2. Pyy, it's -10. Pxy is 4. That makes things easier when I got numbers. So I want to find D. D is Pxx evaluated at that point 7,5 times Pyy evaluated at the same point minus Pxy evaluated at the same point square. So the first one is -2, the next one is -10, the last one is 4 square. That's 20 minus 16, which is 4. That's positive. Now we need to look at Pxx. Pxx is -2. It's negative. So if D positive and Pxx negative from these two, we confirm that the point 7,5 is a relative maximum based on the D test. Now to find each one of each type, what we do is we calculate P at that point, 7,5. P at that point. P of xy was -x squared minus 4x. So if you substitute those in the -x squared plus, we have 4xy minus something square, I think y square, 5y square minus 6x, 5y square minus 6x, almost done there, 22y plus 9, 22 and y is 5 minus 9. If you calculate all of this, I got 43. So the 7 here means, so we have 7,000, because it's in thousands, 7,000 of type A. The 5 means 5,000 of type B. These two quantities should be produced to achieve the maximum profit of the number I got, the 43 million dollars, because the problem said it's in millions of dollars. Any questions about this?